Alrighty, today is a review day, so we are going to be going over the 3 homework assignments that we had this week. So we had on Tuesday, also I should say, you need to get these homework assignments out right now, whether you did them online or on paper. You need to get them out right now, and you need to have a red pen, or you can use a red ink on Google Docs, whatever you want to do. It needs to be in red, and you need to write your corrections. You need to make corrections. So anything you got wrong on these homework problems, we're going to go over every single one. Any of them that you got wrong, you must correct, and then you're going to hand this in by the end of the period. So the assignments that you're going to need are you're going to need the Tuesday 3.1A and 3.1B Part 1 questions. You're going to need from Wednesday the 3.1B Part 2 questions. And then from yesterday, you're going to need the 3.1 A and 3.1B review problems. So you need all 3 of those assignments, and we are going to go over all 3 of them right now. So if you need to take a very quick 1 minute, 2 minute pause on the video so that you can get these assignments together, I would do that. Alright, so first we have this assignment from Tuesday. So first, number 1 says draw the vector diagram for the following scenarios. So letter A says, I'm going to answer them next to it here. Letter A says, a boy walks to school at a speed of 1.5 meters per second at a 135-degree counterclockwise rotation from due east, and the scale given is 1 centimeter per meter, or equals 1 meter per second. So what you need to do is draw the vector diagram. So remember, there are 4 components, 4 components of a vector diagram that we're going to need. We're going to need our axis. Well, the axis is not one of the components, but I'm going to put an axis here. All right. Okay, so remember, those are the four things we need for each component of our, those are the 4 characteristics that we need for our vector diagrams. So our scale, let's do that first. We have 1 centimeter equals 1 meter per second. And so for full credit, you have to write this. I'm going to keep going in red, actually, because you should be writing your answers in red also. So it says he's at a 135 counterclockwise rotation from due east. So if we go 90 degrees and then we go 90 more, we're at 180. So it's somewhere over here, pointing somewhere over here in the left quadrant, upper left quadrant. So 135 counterclockwise rotation from due east. If you struggle to figure out how far, where the angle is going to be, what you can do is you can do 135 minus 90, because we have a 90-degree angle here. And so what we get when we do that is 45 degrees. So we have an arrow going we got to do it to scale, don't we? So let's say this is 1 centimeter and this is half a centimeter. Okay, so here we have 90 degrees plus 45 degrees is a 135-degree angle. So that's 135 degrees. There's my direction. My magnitude is 1.5 meters per second. I got my arrow and I got my scale. So there we go. That would be the correct full complete answer for that one. Letter B, I'm going to go through these quick. So if you are struggling or you don't understand one of them, this video is not going to be erased, so it will be on there today and for all of time, so you can go back and watch this video by yourself if you're not understanding how I got my answers. And you can ask me questions as well. Okay, so letter B, same thing. We have I'm going to draw this axis. My scale given is 1 centimeter equals 100 meters. And it says that a boulder rolls 900 meters down a hill in a direction that is 220 degrees west of south. So of south, meaning we're starting at south, and we're going to go 220 degrees in the westward direction. So here is 180 degrees. So what we need to do now is figure out how many more degrees we have left. So 220 minus 180 is 40 degrees. So we're going to be about right here in this direction, and I need to make sure that I am to scale, and I did not give myself enough room. Alright, so in order to be to scale, I have to do, it's almost halfway, there we go. So 9 centimeters. So this is 900 meters. So I have my magnitude, my direction, or I have my angle here. My angle is 220 degrees. And I have my arrow and my scale. So that is my complete answer for letter B. Okay, for C, it says that a car moves with an acceleration of 15.5 meters per second squared in a direction that is 45 degrees east of south. So first, my scale given is 1 centimeter equals 5 meters per second squared. Then I'm going to look at 45 degree angle east of south. So we're starting at south of south. So we're going to go 45 degrees this way, which is halfway between, in the middle of the quadrant there. So our line, our arrow, is going to be this way. And how many, well, let me see, what is it? 15.5. So it's going to be about 3 1/4, yeah, about that long. So this is 15.5 meters per second squared. The angle I'm working with is 45 degrees. And there we go. That's everything for that one. All right, and finally, letter D says that Ailey pushes a toy truck with 16 newtons of force across the floor in a direction that is 100 degrees in a counterclockwise rotation from due east. All right, so my angle is 100 degrees counterclockwise from due east. So this is a full 180, so I don't want to go all the way that far. So what I'm going to do is I'm going to subtract 90 from 100, which is 10. So I'm about right here. And I'm going to need 8 centimeters here. Let's say that's 8 centimeters. And this is 16 newtons. And my angle here is, oh wait, no, that's right, is 100 degrees counterclockwise of due east. All right, there we go. That is it for number 1. Number 2 asked you to write 3 of your own scenarios and draw the vector diagrams for each scenario, so I can't really go over that one. Number 3 said to find the resultant vector in the following problems using Pythagorean's theorem. For credit, you must show all of your work. If you are unable to solve the problem with the given information, write different method required. So A says that Yusra is on a jog. Yusra runs at 1.2 meters per second southward. Then she stops for 5 minutes and runs 1.1 meters in the westward direction. Draw a vector diagram that depicts Yusra's overall displacement. So Yusra, let's get our axis. We're going to start at the very center here, at the origin. She runs 1.2 meters in the south, 1.2 meters per second, I guess, isn't it? 1.2 meters per second in the southward direction. Then she stops for 5 minutes, but she doesn't say anything about her moving. She just stops. So then she runs again. Oops, I should have put this in the opposite. Dang it. There we go. So then she runs in the 1.1 for whatever speed she's going at, 1.1 meter per second in the westward direction. Draw a vector diagram that depicts Yusra's overall displacement. This was meant to confuse you, but it does nothing to our overall vector or resultant. So remember, when we're trying to figure out the direction of the resultant, we start at the origin and we point it over here. So we start at the starting place, and the head of the arrow is at the finish, and that is our R. So R equals C squared, remember, and C squared equals A squared plus B squared. This is Pythagorean's theorem. So what we need to do here, we have this equals 1.1 meters per second squared plus, so this is going to be c squared, equals plus 1.2 meter per second at, is she accelerating? Did I write? Yeah, and we're squaring that. Never mind. Okay, so when I plug that in, I get that c squared equals 2.65. If I take, then this is equal to r. If I take the square root of, let's erase this, I don't want to confuse you. Take the square root of both sides, I get that c equals 1.63 meters per second, which is equal to r. So our resultant is 1.63 meters per second. And in this lesson, I wasn't asking you to find the direction. I was only asking you to find the magnitude. So we're not going to find the direction for this one. You were only asked to find the magnitude. Okay, now letter B says, Mahfoud takes his pet cow for a walk. They walk at a constant speed for the entirety of the walk. They first go 65 meters in the eastward direction. So they go 65 meters east. And then they turn right and go north for 155 meters. Well, I'm going to shorten these up. There we go. Right and go north for 155 meters. Then they turn back around and go south for 155 more meters. So then they turn around exactly and go back this way for 155 meters. Draw a vector diagram that depicts their overall displacement. Well, their overall displacement is just this vector diagram because this one gets canceled out. So this was kind of a trick question. 65 meters, there's your answer for that one. Super simple. Except you also needed to do a scale. So whatever your scale was. And I think I forgot that with USRAs. You needed to have a scale for USRAs as well. So 1 centimeter equals 1 meter per second. Or if you wanted to do decimals, that's fine too. Okay, so if you wrote different method required, that's okay, but the correct answer is really that. So this is just going back to displacement like we did so many ages ago. Letter C says that Ira crawls 5 meters eastward at a speed, so he crawls 5 meters eastward at a speed of 0.5 meters per second. Then he turns left and crawls 1 meter in the northward direction. 1 meter north. Then finally he turns and crawls 2.5 meters in the southward direction. So we went, did I do that right? East, north, and then, yeah. And then 2.5 meters in the southward direction. So technically this is a different method required. You could solve for this one, but if you wrote different method required, that's fine. And that is we're just going to call that the right answer. If you tried to figure out what this is from here, from here to here, I will give you extra credit for that. But because I thought that I meant to go westward, but anyway, so yeah, if it had been westward, I meant to do westward 2.5 meters. So the path he was supposed to take was supposed to look like this. To the east, to the north, and then to the west. And then your answer would be different method required, right? You'd have to use the head to tail method because we can't solve for resultants with 3 arrows, only 2 arrows. So technically you could solve this. You just have to figure out how long this would be, right? Whoops. Keep doing that. This would be, rather than 2.5, this would have been 1.5 meters because we had 2.5 going this way, 2.5, but we had already gone 1 meter up north. So anyway, if you did that, then cool, I'll give you extra credit or a bonus point or something. But if you wrote different method required, that's right too. Okay, now we're on letter D. Lena runs 4.5 meters per second, screaming her head off. She travels in the direction that is 95 degrees counterclockwise from the east Then she turns and runs northward for 10 kilometers. So immediately you should say, well, this isn't, it would look like this. 95 would be somewhere like right here. And then she turns and runs exactly north. So you should see right away we can't do anything with this because these are not right angles, right? So not a right angle, different method required, which we are not learning that method. So, all right, that is it for this homework assignment. Now moving on to Wednesday's assignment. Short and sweet. All right, Wednesday's assignment says to find the direction of the resultant vectors in each of the following scenarios. You must draw vector diagrams for full points. So find the direction of the resultant. So we're going to have to use the trigonometric method for each of these. So number 1A says George walks 5 kilometers in the northward direction. So he walks, let's just make this a little smaller. All right, so he walks 5 kilometers north. Then he turns and walks 12. This is too long. We're going to make this a little shorter. It's going to be 5 kilometers north, then 12 kilometers in the east direction. And 1 centimeter equals 1 kilometer in this situation. Alrighty. So now we need to know the direction of his resultant. So you have to do the Pythagorean's theorem method in order to find the length of r. Then you can find the direction. Okay, so first we've got to find the magnitude of r. In order to do that, r equals a squared plus c squared equals a squared plus b squared. When I plug that into a calculator, I get c squared equals 169. When I take the square root of both sides, I get c equals 13. So my resultant is 13 kilometers. All right, but I'm not done. Now, what I need to do is I need to use the trigonometric method to find the direction of r. All right, so let's move this up and over. All right, there we go. Okay. So what we're going to do now is find the direction. And the way that we're going to do that is the trigonometric method. So where is the angle that we're looking for? Well, if I imagine this on an axis like this, remember the angle that I'm looking for is this one, theta. Right? That's the angle I'm looking for. And then once I know that angle, I can find the outer angle right here. Because I have to put this in. Does it say to put it? Yeah, well, it doesn't say to do it, but I think I told you that you need to do that. I did. You have to put it into the counterclockwise of east convention. So, here we have theta. Let's use just the SOHCAHTOA method. SOH TOA. I'm just going to do sine because that's the first one. Sine of theta equals the opposite, which is 12 kilometers, over the hypotenuse, which is 13 kilometers. So I get sine of theta is equal to 0.16. Then I take the inverse sine of both sides, and I get that theta equals... Oops, I made an error. This should be 0.016, and we're going to take the inverse sine of that side, of that number. Oh, I made 2 mistakes. Kept getting an answer that didn't make sense. Okay, 12 divided by 13 is not 0.016. It doesn't make any sense. 12 divided by 13 is 0.92. Now we'll take the inverse sine of that, and we will get the right answer. which is 67 degrees. So theta here is 67 degrees. So that means that the resultant, we have to, our last step, our third step here, is to solve in the COE convention. So in order to do that, we have 90 degrees in this quadrant. This whole angle here is 90 degrees, right? So what we need to do is subtract 67 degrees from 90 degrees. And when we do that, we get 23 degrees. So the resultant, the direction of the resultant is 23 degrees counterclockwise of east. So that is your answer for this one. For what was that? Was that only the first one? Yep. All right. Okay, letter B says that a girl rides her bike 20 kilometers southward, then 10 kilometers westward. 20 kilometers, so 1 centimeter equals 10 kilometers. We're going to do 20 kilometers south. Is she going to go west next? Is that what it said? Yes. 20 kilometers south, 10 kilometers west, and now we need to know the resultant. The resultant then the square root of both sides, and we get here that the resultant is 22 kilometers. Now we can use that information in order to solve for our theta. Remember, we have this axis like this. Boop, boop. Okay. All right, and if you don't want to solve for the resultant every time, instead of doing sine, using the opposite and the hypotenuse, or instead of using cosine, which is the adjacent and the hypotenuse, you could use tangent, which is just the opposite and the adjacent. Then we don't need to solve for the magnitude, since this question really isn't asking you for the magnitude. It was only asking you for the direction of the resultant vectors. So you could have done it that way too if you wanted to be faster. So let's do it that way, even though I already solved for the hypotenuse. Whatever. So the tangent of theta equals the opposite, which is 10 kilometers, divided by the adjacent, which is 20 kilometers. Then I get tan theta equals 0.5 kilometers. And the inverse of the tangent of those both sides gives me that theta is equal to 27 degrees. So I need to get this into eastward, or counterclockwise of east convention. So I have to add 90 degrees to this. And when I do that, I get a 117 degree counterclockwise of east direction for my resultant. Okay, let's do... Oops, I always do that wrong one. Okay, now we're on D. Okay, so now we're on letter C. Miss Montgomery drives 8 kilometers in the westward direction. So I'm going to do a scale. 1 centimeter equals 2 kilometers. She's going to go 8 this way. Then she's going to go 10 this way. And the question wants to know what is the direction of the resultant. So this time I'm just going to use the tangent again, because then I don't have to solve for the hypotenuse. Remember, TOA. So I need the opposite. So the angle that I'm looking for here. Where's the angle that I'm looking for? So she started... Wait, I did the arrow the wrong way, didn't I? Darn it. It should be pointing this way. Everybody makes mistakes. Everybody has those days. You know that song? Probably not. Okay, there we go. So this is the axis or the compass that we're looking at. So our theta is here. So the opposite would be 10 kilometers divided by 8 kilometers gives us tan sine equals 1.25 kilometers. Take the tangent inverse of both sides, and we get that theta is equal to 51 degrees. All right, but that is not quite correct, because this direction that we're looking at here is 51 degrees south of west, right? If we're starting at west, we're going in the southward direction, but what I want, the convention I need is in the counterclockwise of east convention. So I'm going to have to add 180 plus 180 here. So plus 180 degrees gives me theta, or not theta, but the direction, resultant direction equals 231 degrees. There we go. All right, letter D. François goes for a jog. He runs 2.25 kilometers east. Then he runs 1.75 kilometers south. All right, so I'm going to say 0.75, 1 centimeter equals 0.75 kilometers. No, I'm going to do halves, actually. 0.5. 50. Okay, so we have 2.25 going kilometers going to the east, and then he runs 1.75 to the south. I am again going to, here we have going this way, so my axis is like this. My theta would be here. Alright, so what I'm going to do here is I'm going to do tangent again, toe up. Tangent of theta is equal to the opposite, which is 1.75, divided by the adjacent, which is 2.25, which gives me 0.78. If I take the inverse tangent of both sides, I get that theta equals 38 degrees. But what I'm looking for is not actually that. Ooh, this is a good one. So what we need to do is figure out what is this angle right here, right? Because this whole thing is 90, but I need to know what this little one is so that I can add it then to all this 270 on this side. So I think that I can get a counterclockwise of east rotation. So in order to do that, 90 minus 38 is 52 degrees. So this is 52 degrees. Then I want to start at east, and I want to go all the way around to here to know what direction my resultant is in. So in order to do that, I have to add 90 plus 90 plus 90, which is 270 to 52, and that gives me 322. So my resultant is 322 degrees counterclockwise of east. And finally, we have our last one here. It says a dog walks 2.2 or 2.3 kilometers in the northwestward direction. Ooh, this is a good one. I'm going to draw. Anytime you see a northwestward one, it might, or one that's not perfectly north, south, east, or west, it might be easiest for you to draw the actual the axis first before you start drawing the lines. So he walks 2.3 kilometers in the northwestward direction. My scale is 1 centimeter equals 1 kilometer. Alright, then he walks 9.7 kilometers in the southwestward direction. Southwest is this way, right? So he would walk 9 kilometers over here. So this is 9.7 kilometers. This one is 2.3 kilometers. Remember, I said it doesn't have to be perfectly north, south, east, or west. It can still be at a right angle using northwest and southwest, like it is in this situation, for example. So what we're going to do, we do have a right angle right here. So we're going to find this resultant right here. This is R. Okay, so this is theta right there because it's closest to the origin. So what am I going to do? I'm going to do tangent. Tangent of theta equals the SOHCAHTOA. The opposite, which would be 9.7 kilometers, divided by the adjacent, which is 2.3 kilometers. That gives me tangent theta equals 4.2. Then I take the inverse tangent of both sides, and I get that theta equals 77 degrees. So this is theta right here. Right here. Right? This is theta. So what I need to do is put this into the east counterclockwise of east convention. So I'm going to subtract 77 here. Wait, can we do this? Actually, we can't do this. Ooh, interesting. I forgot about that. Okay, well, then you would just say that theta is 77 degrees, but if you're going to say that it's 77 degrees, you have to say in what direction we're talking here. So, you would say 77 degrees. This is in the south, right? Because this is under the westward one here, right? So we would say south of northwest. Ooh, right? Because we're starting at northwest of northwest. This is northwest, pointing in the northwestern direction. We're going south. So this answer is that the resultant is in the direction that is 77 degrees south of northwest. Oof, that's a nice one. Alrighty, that is it for Wednesday's assignment. Let's see how much time we have left. Alright, so now with these with this information that I've given you, these corrections that I've given you going over these first two assignments, what I want you to do now is you're going to go back to this Thursday assignment, the assignment from yesterday, and you're going to make super duper 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 sure that you have all of the answers right on there. You're going to go back and you're going to find any mistakes that you may have made based on what we've done today in these two assignments. Okay, so this is the one that you're really getting graded on. You get the most points for this one. So I want you to make 100% sure that you have all the answers right on there, that you make the correct adjustments based on what we went over on here and on here. So individual corrections on Thursday's assignment, on this assignment, and then you're going to hand in all three homework corrections in the same doc on today's assignment, today's post. This is before the end of class, so in the next 10-15 minutes. Okay? And that is it. Be sure that all these are in red. Be sure that they're all in one single doc, so you could just copy and paste or take pictures and put them all in the same document. And that is it for the homework corrections. For Monday, we are going to be moving on to 3.1 C and D. So that's what we'll be doing on Monday. You don't have any homework. Let me make sure that is everything. I think it is. Yep, that's it. All right, so finish up your corrections. Make sure you really have the correct answers on here based on Thursday's assignment based on what we've done today in the first 2 assignments. So, and that's what I wanted to say. If you want me to go over any of the problems from this assignment, then leave a leave a comment on Google Classroom. Comment on about any of the problems you want me to do on Monday. You need to do this also before the end of class. Leave a comment before the end of class so that I can make the lecture for Monday. Okay, thank you. Let me know if you have any other questions. Have a good weekend. Goodbye.